Hello students, I hope you all are doing fantastic out there. So we are doing heights and distances, exercise 22b from ICSE book of class 10, isn't it? So we have completed till question number 12 in our previous videos, and today we'll start right from question number 13 and we will complete this chapter in this video. Okay, so let's begin. This is question number 13. The length of the shadow of a tower standing on level plane is found to be 2y meters longer when the sun's altitude is 30 degree than when it was 45 degree. Prove that the height of the tower is y into root 3 plus 1 meters. Okay, so let us understand this question by drawing a diagram. So let us assume this is a tower, okay, and this is the horizontal plane. Now these two are the cases when the shadows are formed. Okay, shadows of tower are formed when the sun's altitude is 30 degree. When the sun's altitude is 30 degree, the shadow was this much long. Okay, shadow starts right from the foot of the tower to this point. The length of the shadow is this much long when the sun's altitude is 30 degree. Now when the sun's altitude changed to 45 degree, means when the sun rose high up, the shadow became a little shorter, isn't it? 45 degree, the length of the shadow is this much. When the sun's altitude was 30 degree, the length of the shadow was this much, and when the angle of depression changed to 45 degree, when the sun's altitude changed to 45 degree, the length of the shadow is this much. By how much meters did the shadow change? By 2y meters. Okay, the distance from this point to this point is 2y meters. Okay, now let us name this A, B, C, D. So we are asked to prove the height of the tower AB is y into root 3 plus 1 meters. I hope you got the question. Now let us proceed to solve this. Let the height of the tower be x meters. Okay, let the height of the tower be x meters. We are assuming the height of the tower, that is AB, is x meters. Okay, in triangle, let us check out smaller triangle ABC. In triangle ABC, we have AB, that is height of the tower, AB equals to x, isn't it? And angle ACB equals to 45 degree. Angle ACB equals to 45 degrees, isn't it? ACB, C should be in the middle. Okay, so applying tan theta, we can find BC. Since tan of angle ACB equals to tan theta means perpendicular upon base, so AB will be the perpendicular. AB by base is BC, isn't it? Or tan ACB means, tan of ACB means 45 degree equals to AB is x. We have assumed AB is x. BC, we do not know the value of BC, we write BC. Tan 45 degree means 1 equals to x upon BC, or BC into 1 is BC equals to x. This is equation 1. Okay, so the length of BC is x meters. The length of BC is x meters. We found the length of BC to be x meters. Okay, now let us see the bigger triangle, that is triangle ABD. In triangle ABD, we have AB, that is the height of the tower, isn't it? AB equals to x meters, and angle ADB, okay, this angle ADB. Angle ADB equals to 30 degree. Let us apply tan theta. Tan of angle ADB equals to perpendicular AB by base BD, isn't it? BD. Or tan ADB is given to us 30 degree. AB is X, isn't it? X. BD means BC plus CD. So we write BC plus CD. If we add BC and CD, we get BD. Or tan 30, the value of tan 30 is 1 upon root 3 equals to X upon BC. BC means X, isn't it? We found BC equals to X from equation 1. BC equals to X plus CD. Oh, CD, we have the value of CD, isn't it? What is CD? CD is 2y. CD is 2y meters. This is given, isn't it? 2y meters. The length of the shadow extends 2y meters when the altitude changes from 45 degree to 30 degree, isn't it? So let us cross multiply this. X plus 2y into 1, X plus 2y, X plus 2y into 1, X plus 2y equal to root 3 into X, root 3x. Okay, so 2y equals to root 3x is already in the right hand side. Let us take this plus x to the right hand side, minus x. Or let me bring this whole thing here. Root 3x minus x equals to 2y. Okay, let me continue here. I bring everything to the left hand side and I take everything to the right hand side. The sign does not change when I do that. Okay, so x and x are taken common, or x is taken common. Within the bracket remains x into root 3. X into root 3 gives us root 3x. Plus into minus gives us this minus. X into 1x, isn't it? Equals to 2y. Or x equals to 2y is already in the right hand side. So let us cross multiply this. Root 3 minus 1 goes to the denominator. Root 3 minus 1. Let us rationalize this. Okay, rationalize means if we have minus sign here, we multiply with plus. Root 3 plus 1 upon root 3 plus 1. If we have plus sign here, we multiply with root 3 minus 1, root 3 minus 1. Okay, or x equals to 2y into root 3 plus 1. 2y into root 3 plus 1, isn't it? In the denominator we have root 3 minus 1 into root 3 plus 1, which is a minus b into a plus b. That means a square minus b square. So root 3 square is 3 minus b square means 1 square is 1. Or x equals to 2y into root 3 plus 1 divided by 3 minus 1 is 2, isn't it? So 2 cancels out. Therefore x equals to, let me write here, okay? Therefore x equals to y into root 3 plus 1, isn't it? Y into root 3 plus 1. And what is x? X is the height of the tower. So we were asked to prove the height of the tower is y into root 3 plus 1. Therefore the height of the tower is root 3 plus 1 meters. Okay, so this is proved. I hope you got this. Now let us move on to the next question. Okay, from this point I started here. To question number 14. An aeroplane flying horizontally 1 kilometer above the ground and going away from the observer is observed at an elevation of 60 degree. After 10 seconds, its elevation is observed to be 30 degree. Find the uniform speed of the aeroplane in kilometer per hour. Okay, so we are asked to find the speed of the aeroplane in kilometer per hour, isn't it? So let us understand this question by drawing a diagram first. So suppose aeroplane is flying horizontally, okay, like this, at a particular height. It's not changing the height, okay, and this is the ground. This is the ground. This is the line where the aeroplane is flying, isn't it? So suppose the aeroplane is here, and at this point the height of the aeroplane from the ground is 1 kilometer. This is given to us, isn't it? 1 kilometer above the ground. Okay, the aeroplane is flying in this direction, going away. So an observer is somewhere here in the ground and observes the plane at an angle of elevation 60 degrees, isn't it? So when observer from the ground observes the aeroplane, the angle of elevation made at the time is 60 degree. Okay, this is the angle of elevation. Now after 10 seconds, the aeroplane reaches somewhere at this point, isn't it? The aeroplane is flying in this direction, means it reached somewhere here. We don't know exactly where the aeroplane reached, but we can assume the aeroplane reached here. Okay, suppose. Now at this point, the angle of elevation when the observer sees the plane is, suppose this point, okay, this point, angle of elevation is decreased to 30 degree. 30 degree. Now we are asked to find the speed of the aeroplane in kilometer per hour. So let us join this down. Okay, now you can see two triangles, isn't it? Suppose this is A, this is B, this is C, this is D, and this is E. So AE is the distance covered by the aeroplane in time 10 seconds, isn't it? So distance AE divided by time 10 seconds, distance AE divided by time 10 seconds gives us the speed of the aeroplane, isn't it? So our main motive is to find the distance AE. Okay, so let us first see the rectangle ACDE. This is a rectangle, isn't it? ACDE is a rectangle. So rectangle means the opposite sides are equal to each other. This means in rectangle ACDE, you can see CD and AE are equal. CD equal to AE equal to distance covered by the aeroplane, covered by the, isn't it? CD and AE are equal to each other. These two sides are the opposite sides of rectangle, and similarly AC and ED are also equal. Okay, AC equal to ED. ED equals to height at which the plane is flying, isn't it? So this is equal to 1 kilometer, isn't it? This is given to us 1 kilometer. 1 kilometer, okay, 1 kilometer. Now let us first talk about this triangle. Okay, triangle ABC. In triangle ABC we have AC equals to height at which the plane is flying, that is 1 kilometer, isn't it? And angle ABC equals to 60 degree, isn't it? ABC equals to 60 degree. So let us apply tan theta. Since tan of angle ABC equals to perpendicular is AC by base is BC, or tan of angle ABC is given to us 60 degree. AC, we know AC is 1 kilometer, isn't it? 1. So BC means we don't know the value of BC, we are trying to find the value of BC. Okay, so tan 60 means √3 equals to 1 upon BC. Let me continue here. BC equals to BC equals to root 3 goes down to the denominator, isn't it? By cross multiplication, 1 upon root 3. This is equation 1. Okay, BC equals to 1 upon root 3. So we found BC from this triangle ABC. Now we see the triangle EBD. Okay, EBD. In triangle EBD, ED equals to ED and AC are equal, isn't it? ED and AC are equal to AC equals to 1, isn't it? 1 kilometer. And angle EBD, this angle EBD, this angle equals to 30 degree. Okay, so tan of angle EBD equals to perpendicular is ED by base is BD. So we write BD here. So tan EBD means 30 degree equal to ED. ED is AC equals to 1. So we write 1. ED equals to AC equals to 1. So BD means BC plus CD. Total BD means BC plus CD, isn't it? So BC plus CD, or tan 30 means 1 upon root 3. We write the value of tan 30. 1 upon BC. What is BC? We found the value of BC. BC is 1 upon root 3 from equation 1. 1 upon root 3 plus CD. We don't know the value of CD. Okay, we are trying to find the value of CD. So 1 upon root 3 equals to 1 upon root 3 plus CD, isn't it? So let us cross multiply this. 1 upon root 3 plus CD into this 1, or 1 upon root 3 plus CD, isn't it? Equals to root 3 into 1, root 3, or CD equals to, this root 3 is already in the right hand side. Let us take this 1 upon root 3 to the right hand side, becomes minus 1 upon root 3, or CD equals to, 1 is in the denominator, so LCM of 1 and root 3 is root 3. Root 3 into root 3, 3 minus 1 into 1 is 1, or CD equals to 3 minus 1 is 2 by root 3, isn't it? So let us rationalize root 3, this gives us 2 root 3. 2 into root 3 is 2 root 3 divided by root 3 into root 3 is 3. CD, the value of CD is 2 root 3 by 3 meters, isn't it? 2 into root 3, 2 root 3, root 3 into root 3, 3. Okay, we found CD. CD is actually equal to AE, isn't it? We wrote CD is actually equal to AE, distance covered by the plane, isn't it? So let me erase this, please take the screenshot. So we found CD. Therefore, distance covered by the plane equals to 2 root 3 by 3 kilometers, isn't it? And time taken by the plane, time taken by the plane equals to 10 seconds, isn't it? 10 seconds. So we are asked to find the speed in kilometer per hour. So let us convert this second to hour. Okay, 10 divided, this is in seconds, divided by 60 gives us minute, isn't it? When we divide second by 60, this is converted into minute. So again we divide by 60, this is converted into hour. So this is hour. 0 0 cancels. 1 is in the numerator. In the denominator we have 6 6 36, and this 0 remains here. 1 upon 360 hours. So we found the time, we already have the time, we found the distance. Now we can find the speed, isn't it? Therefore, speed of the plane equals to distance upon time, isn't it? Distance upon time is the speed. So let me erase this and write, okay? What is distance? Distance is 2 root 3 by 3. 2 root 3 by 3. Upon what is time? Time is 1 upon 160. 1 upon 360. So this gives us 2 root 3 by 3 into this 360 goes to the numerator, divided by this 1 comes down here. 3 1s are 3, 3 1s are 3, 3 2s are 6, 3 0 0, isn't it? Let me erase this, okay? So we have, or in the denominator we have 1, so we need not write that. So in the numerator we have 2 into 120 into root 3, okay? So 2 12s are equal to 2 into 12, 24. So this 0 we write here into root 3. 2 into 120 into root 3, isn't it? So 2 into 120 is 240. Root 3 means 1.732. Now we multiply these two numbers, okay? Let me multiply here. 1.732 divided into 24. So 4 2s are 8, 4 3s are 12, 2, 4 7s are 28, 29, 4 1s are 4, 5, 6. 2 2s are 4, 2 3s are 6, 2 7s are 14, 2 1s are 2, 3. So this is 8, 4 plus 2 is 6, 9 plus 6 is 15, 6 plus 4 10, 11, 3 plus 1 is 4. And we have 0 here, isn't it? So 240. This means we put 0 here. Now we put decimal point before 1, 2, 3 digits. 1, 2, 3 digits. So 415.68. 415.68 kilometer per hour. So speed of the plane is 415.68 kilometer per hour, okay? So when we calculate this, we get this. So we found the speed of the aeroplane which we were asked to find, isn't it? So let us do question number 15. Okay, now let us do the last question from this exercise, question number 15. From the top of a hill, the angles of depression of two consecutive kilometer stones due east are found to be 30 degree and 45 degree respectively. Find the distance of the two stones from the foot of the hill, okay? So let us understand this question by drawing a diagram. Let us suppose this is a hill, okay? And this is a horizontal ground. Now, a person is here on the top of the hill and is observing the 2 kilometer stones which are on the ground, okay? 2 consecutive kilometer stones. Please keep in mind consecutive kilometer stones. So he is observing the 2 consecutive kilometer stones on the ground, okay? He is looking downward, means angle of depression, isn't it? So let us draw a straight line parallel to the baseline. These two lines are parallel to each other and this line is a transversal, isn't it? So if this angle is 45 degree, this angle must be equal to 45 degree, isn't it? Because alternate angles are equal to each other. Now another kilometer stone is somewhere away from here, somewhere here, okay? This is the point where another kilometer stone is located. Now the angle of depression at this point is, he's looking downward, isn't it? 30 degree. 30 degree. So this must be equal to 30 degree because these two lines are parallel to each other and this line is a transversal. So alternate angle must be equal. Now the most important thing which we should note is the distance between these 2 kilometer stones is 1 kilometer, okay? Because 2 consecutive kilometer stones, it is mentioned in the question, consecutive kilometer stones, which means consecutive kilometer stones means after 2 kilometer comes the next 3 kilometer, comes the next 4 kilometer, next 5 kilometer, isn't it? It never goes like this. 2 kilometer, 7 kilometer, 13 kilometer, it never goes like this. After each kilometer there will be a kilometer stone, isn't it? So consecutive means the distance between these two kilometer stones is 1 kilometer. I hope you got this. Now let us solve this question. So we are asked to find the distance of the kilometer stones from the foot of the hill. That is, the distance BC is the distance of the first kilometer stone from the foot of the hill, and BD is the distance of the second kilometer stone from the foot of the hill. So we are asked to find BC and BD. Okay, so let us solve this. In triangle ABC, okay, AB equals to height of the hill, isn't it? Height of the hill equals to x kilometer, say. Okay, AB equals to height of the hill equals to x kilometers. We are just supposing x kilometer. Now, and angle ACB equals to 45 degree. So let us apply tan theta. Tan of angle ACB equals to perpendicular is AB, isn't it? AB by base is BC. So we have tan of ACB. Tan ACB means 45 degree. And one more important thing which I would like to tell you is the bigger angle will be closer to the perpendicular line. The smaller angle will be farther away from the perpendicular line. Okay, 30 degree is farther, 45 degrees nearer to this vertical line, isn't it? If 60 degree will be more closer to the vertical line. Got my point? Okay, so we are talking about this. Let us come to the point. Tan ACB means 45 degree. Tan 45 degree is AB. What is AB? AB, we suppose the value of AB is x, and BC we don't know, so we are trying to find BC. So tan 45 means 1, isn't it? The value of tan 45 is 1, equals to x upon BC, or BC into 1 is BC. BC equals to x kilometer. So we found the distance BC, isn't it? This is equation 1. BC equals to x. Okay, this is equation 1. X kilometer actually, but we write x right now because we don't know the value of x, so we write only x. Okay, actually this is x kilometer. Distance BC is x kilometer. That means the distance of the first kilometer stone from the foot of the hill is x. Now in triangle ABD, the bigger triangle, in triangle ABD we have AB equals to x and BD equals to BC plus CD, isn't it? BD equals to BC plus CD and CD equals to 1. CD equals to 1 kilometer, and angle ADB equals to 30 degree. This is given to us, so let us apply tan theta. Tan of angle ADB equals to perpendicular is AB by base is BD means BC plus CD, isn't it? BD means BC plus CD. BD means BC plus CD. Okay, so tan ADB is 30 degree equals to AB. We know the value of AB equals to x upon BC equals to x, isn't it? We found in equation 1 BC equals to x plus this is x, okay, plus CD is equal to 1. CD is equal to 1 kilometer, isn't it? Distance between two consecutive kilometer stone is always 1 kilometer. So what is the value of tan 30? 1 upon root 3 equals to x upon x plus 1. Now let us cross multiply this. X plus 1 into 1, x plus 1. X plus 1 into 1, x plus 1. Root 3 into x equals to root 3x. Or we have 1 here equals to root 3x. Now let us take this x to the right hand side, minus x. Or we bring everything to the left hand side, root 3x minus x equal to 1 is in the right hand side, okay, this 1. Now we take the common x within the bracket, x into root 3, x into root 3, root 3x, minus, plus into minus, minus, x into 1, x into 1, x equals to 1. Or x equals to 1 upon root 3 minus 1. Root 3 minus 1, isn't it? So let us rationalize this. Root 3 plus 1 upon root 3 plus 1. Or x equals to 1 into root 3 plus 1 is root 3 plus 1 divided by a minus b into a plus b, isn't it? Root 3 is considered as a, 1 is considered as b. So a minus b into a plus b is a square minus b square. So root 3 square is 3 minus 1 square is 1. Okay, so let me erase this. So x equals to, please keep in mind bc equals to x. bc equals to x, okay. We found in equation 1, isn't it? So, or I'm continuing here, x equals to root 3 root 3 plus 1, isn't it? So root 3 plus 1 is 1.732. Root 3 means 1.732 plus 1 divided by 3 minus 1 is 2. Or x is, value of root 3 is 1.732, okay. So 1 plus 1 is 2. 1 plus 1 is 2.732. 732 divided by 2, isn't it? So 2 ones are 2, 2 ones are 2. This point we put here 7, isn't it? So 2 3s are 6, 7, 1, 2 6 are 12, 13, 1, 2 6 are 12. So x is BC, isn't it? Actually x is AB and AB is equal to BC. So we found the distance between the foot of the hill and the first kilometer stone. Therefore, distance between the foot of the hill and first kilometer stone equals to 1.366 kilometers. Okay, so now we will find BD. Okay, so what is BD? BD means the distance of the second kilometer stone from the foot of the hill, isn't it? And distance of the second kilometer stone from the foot of the hill equals to BD, isn't it? BD means BC plus CD. BC plus CD, isn't it? And what is BC? BC is x. X is 1.366. 1.366 plus CD, and CD is 1 kilometer. CD is 1. So we write 1 here. So let me continue here. So this gives us equal to 1.366 plus 1 is 2.366 kilometer. So we were asked to find the distance of the first and the second kilometer stones from the foot of the hill. So distance between the foot of the hill and first kilometer stone is 1.366 kilometer, and distance of the second kilometer stone from the foot of the hill is BD, that is 2.366 kilometer. I hope you got this. This was an easy question, isn't it? So this was for today. Thank you so much. I'll upload the next exercise in the next video. Okay.